How's it going, YouTubers? Electron Man, we got a fun project today. We're gonna take one of these little, you get them for like $20 off of Amazon frequency counters, and we're gonna build a little frequency counter with a case. Fortunately, I do have a 3D printer, so ahead of time, I went ahead and printed out this this case off my 3D printer. This is just PLA. It did a really good job. I can provide you with the STL. It's on Thingiverse is where I found the 3D rendering of it. But anyway, I printed this box, and this is the back cover. And I put a chrome front on it. I kind of wanted to dress it up. You don't have to do that, but that PL was kind of not real smooth. I thought a chrome front would be cooler. But anyway, the parts involved in this is, of course, I printed this 3D case. It also printed these little 3D buttons that will that go onto the two buttons that will display on the front of the case. That'll come through here and that. But anyway, I printed the case, and I purchased this off Amazon, this little frequency counter. And then you'll need I'm going to make mine portable. I could just run a positive and negative out. It needs 12 volts to run. But I actually had one that went bad on me that was portable, and I kind of like the portability of it, as long as you don't forget to turn it off. But it's got bright LEDs and a 8 AAA batteries. Should give me really good runtime. I could have went with a 9-volt battery, and this will run off 9 volts. But I decided it's cheaper actually to get AAA batteries than it is 9-volt batteries, and this will give me more milliamp hours to run. So I mean, it's probably a couple days running there. It'll probably last me a long time as long as I don't forget to turn it off. But anyway, I'm rambling on here. But anyway, you need a 12 volt. This is, I just ohmed it out with batteries. It's 12.6 is what it is. So it's 12 volt supply for the frequency counter. And I printed out the box, and then you'll need a BNC connector. That's for your input for the fric counter. And then I'm going to go ahead and wire a switch. And this is actually a single throw double pole, which really a single throw single pole would work, but it's what I had on hand. But anyway, we'll mount this. This is actually where the power wires are supposed to go out, but I'm gonna go ahead and mount the switch back there so that for my on and off switch on the back to turn it off and on. So anyway, the first thing we're gonna need to do here is we're gonna need to solder up my my BNC, my signal wires for the plug that goes in here. And you need to be real careful on this. One side shows positive, negative, the other one shows ground and signal, sine wave, or freak. So this is the frequency side. Don't get them mixed up, because you put 12 to that, it could really hurt it. And the other one says positive and negative. And if you hook them backwards, I was looking, if you hook these two, they fit in each other, but the polarity's backwards if you hook the signal wire into the power one. And that sure could, hooking up negative or 12 volts positive in a negative circuit could definitely do damage to this little unit. So just pay attention to that. But anyway, first, I know this is a signal wire that plugs in here. So the first thing I'm going to do is I'm going to take and I'm going to solder on my BNC female connector on the front, so that I can have it on the front of the box to connect either an antenna, if you want to just catch it through RF, or obviously a BNC cable to the back of whatever equipment you want to test. You want to attenuate it that way. But if you're watching this, you probably know about how to use a frequency counter. So anyway, the first thing we're going to do is we're going to go ahead and solder this guy up, and obviously positive is going to go to the positive lead. These little vices are kind of handy too, just to hold the wires while I solder it. But anyway, let me go ahead and, too bad it don't stick on there, but get this in there where I got a third hand. Basically, that's what I'm needing. And all I'm going to do here is I'm going to solder iron out here. Get some solder, and we'll go ahead and tin it up a little bit before we solder it in there. Okay, I now have this one soldered. This is the positive side of the signal. On this one, it's a little bit tricky because of the fact that I've got to fit it through this hole in the front and put a nut on the back. I had to spin the wire through and put the nut and the washer on this side of it to make sure that once I push it through. So you really got to pay attention to that. You'll be unsoldering it like I actually did a couple times to figure out which way I need to do it. But see, now that I've got the signal wire, I can just fit it in the hole on the front, and now I need to just slide the nut and the ground strap down and tighten the nut down, which even that's going to be a little bit of a challenge. Let me go ahead and work that down, but I can do it. It's going to take me a minute to get her set on there. But yeah, the only critique I would put on this box is I wish that the face plate, instead of the backing plate being like it is, I almost wish the front plate was with the one with the screws, so it'd be a lot easier to get to these connectors up front here, because I'm obviously having to reach through the box to get them, but it's not possible. It's just going to take me a minute to fiddle with it. But anyway, we'll get back to it when I get this nut on here and get this ground tightened down with the front BNC secured, and then we'll go on to the next step. Okay, I now have the BNC connected on the front, as you can see, with the nut on the back. Hopefully you can see in there and see how I got that. And basically it was just once I got the nut started, I was able to just use a flat blade and kind of work the screw around. And once I got it started, then I could just hold the nut and screw the front, since the wires were not connected on the back. They could just turn, and got her tightened up. But we got our front BNC connector now, which will plug in to this board right here on this port. So the next thing we want to work on is my battery tray, and that's really going to be pretty easy. Basically what we're going to do is I mount the switch on the back of this backing plate that goes over the back like this. That's going to be my on or off switch. And then what I want to do is I'm going to hook one to the, since it's a double pole, I only need to use one side of the switch, but just make sure you're on the same side of the switch. But I'll hook one lead up there, and then the other lead will go to the battery pack. So basically I'll hook the grounds together, and then I'll hook the positive. I'll hook one lead to the center, and then the other lead to this side of the switch, so that when the switch is in this position, it's on and it's off, and that'll turn the AC on and off. So next thing I do is get this lined up, get these battery wire and power wire for the circuit board mounted. So basically I'm going to take one here and one for my little battery pack, and get those soldered in there. In fact, I'll go out and lined up nice. I'm going to go ahead and get that soldered here now. Make sure you always tin your iron. Oh, don't move on me. I need more hands. Got her. I had to chase her down, but I got her. So now see, I got one on that one, and then let's see, I want the switch to be on that position, turns it on, so that would be on this side of it. So then I just want to take my battery wire, put it on the other side of this switch, other pole, other side, however you want to pronounce that. Fold her over here, and let's put a dab of solder on that one. Hopefully I don't have to chase it around like I did the last one. There we go. We now have our switch wired, which, as you can see, it's just going to go that way and that way. Well, this way. Switch will go in there like this. Make sure to get the signal wires out of the way. Well, let me go ahead and plug them in actually while I'm here. Like so. I don't want to pinch them. Fit it in there. It's a tight fit in this little box, but I've already had it in here once before, so I know it'll fit. You just kind of have to turn it, and then come on, come on, come on, come on. Work with me here. There we go. And there we go. Now we just need to work it around, get it turned in there. lined up. I had it and then moved it. Come on in there. What's holding me up here? Anyway, get it in there, and then there's going to be 4 little screws that go on the back. Let me get this lined up real nice and neat, and we'll be back. Okay, now all I'm going to do is take and hook the negative side of my battery pack up to the power supply here. Okay. Again, I wished I had another set of hands, but we'll just use this as my holder. And then we'll just solder these 2 wires together. I guess you could just hand peel them back, but I prefer to tin them and solder them and put a piece of heat shrink on them. That's the right way to do it. So, I'll tin that one. Tin that one. And hopefully you're able to see this. Sorry, I gotta missed. Let's see if I can do it maybe this way. You can see. Basically, I'm just soldering 2 pieces of wire together here. There we go. And now we got these 2 pieces of wire soldered together. Solid connection. Put a little heat shrink on that. Protect it from shorting anything in there. And the nice thing is I actually found these little double-sided pieces of tape, any piece of double-sided tape. But the battery pack fits in there so snug. You really don't even probably need a double-sided, but I just don't want it scooting around if I were to drop it or something. So I put one little dot of double-sided tape on here, and I'll just slip my batteries in here. You don't want it permanent because obviously you're going to have to come back sooner or later and upgrade the batteries. And then I'm just going to take and feed the battery pack in there. Like I said, it was snug enough. It probably wasn't going to move anyway, but this way just kind of double ensures that. But push down and make sure that double-sided tape sticks. Round leg looks good. Everything looks good. Now I'll just tuck my wires in here. And there's how the back fits on there. And now I don't have the screws for the front. I had to order them, so I'm not going to push the buttons or nothing. They're definitely protruding out, and we're all lined up. There's 4 little screws on the back side there. I had to order some small screws. I didn't have any screws that small. Same for putting these on the back here, but anyway, it doesn't have the screws on, but this will definitely show you that finished product. It should come on now. Bingo. Which I'm not feeding in any frequency right now, so that's to be expected. But come back when I get all the screws in, and we'll give it a final review. Okay, now I got the screws installed in the back of this. I don't know if you can see down in there. Hopefully you can. The 4 little screws that mount to the pre-printed little studs that were on the back of this case I printed. Those were a little bit of a challenge. If I had actually designed this case, I really think I would have went with a front and back removable maybe, or definitely a front, because I had to use a magnetic screwdriver, and it was a challenge to get those 4 little screws in there. And then, of course, you never seem to have the right size screw. I'm tickled Amazon. You know, I've already got like 4 or 5 of these packs, but of course I didn't have the screw size I wanted. I really needed like I think I ended up using what was it? Let's see, I used a M2.6 6mm is what I ended up using. That worked perfect on it, but I had to order a screw kit, which I put all this stuff on as far as what I bought off of Amazon as far as what I needed for that. But anyway, got those 4 screws in. I've got, you know, all my soldering done. There's my little battery pack. Like I said, I put a little double-sided adhesive just to keep the battery from sliding around there, but it fits so tight it's really not going to be a problem. But last thing snap her in there. Like I said, it's a tight little fit. Get my there we go, double-sided tape get hooked right there, and then this is going to be a matter of tucking the wires in nice and neat. I say nice and neat, just tucking the wires in, and then there's how the snap. It snapped on nice. Okay. Now then, all I got left to do is put these 4 back screws on, which you don't need to watch me do that. Let me go ahead and do that real quick. I'll leave it rolling. That looks like that's probably some M.2, maybe 5s. Looks like a little bit smaller screw there. Let's see how that fits. Lining up right? Yeah. Yeah, that's perfect. Now we got one built case here. As you see, there's the finished product, and let's see if she comes on. Ta-da! Look at that. Now then, I wonder if she's actually counting any frequency. Let me see here. I could fire up my RF generator here. Figure out which cable it is. Sorry, guys. Okay, let me go ahead and hook up our generator. Turn it on. And I got it set to negative 20 dB. Yeah, I think we're reading the frequency. There we go. Yeah, I got it set to 25,290. As you can see, as I move my generator, it's going to go up and down. 32 megahertz. Bring her on down, 14 megahertz. Let's change range. 7 megahertz, 4 megahertz, 2 megahertz, 1 megahertz, 573. Basically half a megahertz there. She's still drawing down. The amp going up, going down. Rock solid. There. Anyway, there you go. There is one portable frequency counter built with a 3D printer. Definitely does what I'm going to need it to do. It's a heck of a lot cheaper than buying one. I think it was about $20 for the display. Oh, I didn't pull the little plastic protector off of it. A little bit on the bright side too. I think I might get that plastic protector off of there. I should have pulled that off before I installed it, huh? But then that'd have been too easy. There she goes. Of course, it's 2 pieces. So I got to dig this one out too. Go figure. Are you going to give me grief, or are you going to come up pretty easy, huh? I like peeling these off, but it'd be a little easier if I'd done it ahead of time. There we go. Okay, yeah, and I think you can adjust. It seems like I've seen a couple other videos where you can adjust the brightness. I can't remember which button it is. IF, we don't want IF. Channel A, channel B, that's for high and low. Yeah, that is okay. That's a little dim. Ah. think 3 is pretty good. What do you guys think? Let's get out of here. Yeah, I think 3. Save on the battery a little bit too, but yeah, that's not near as bright. It's almost, that sucker's bright whenever you got it on a high. Let me go back and hook up my frequency counter or my RF generator again. Yeah, there we go. She is just counting away, and that's an analog. It's a BK 2050 generator. If you're curious what I'm using there, but anyway, that's I got her set to 31, and she's kind of fluctuating. I mean, we're talking very little. Anyway, I hope you enjoyed this video. It's quite a little project. I kind of had to stop for a couple of days and get the screws I needed, but she's doing the trick. There you go, and totally portable. And you could have easily, I could have easily either this hardwired in with a little 12-volt power pack, or I could even later, if I wanted to, if I decided to choose the batteries too fast, I could just drill a little hole and leave the switch in and make it to where it's a bench with AC. But I just kind of like the idea of having it portable. We'll see. I think the batteries will hold up good for me. But anyway, I hope you enjoyed this video. It's a pretty long one. Took a little while to build this whole thing. I think it turned out really good. It's cool to utilize my 3D printer and make a little case. And like I said, I got 20. I probably got about $40 in this one, but if I build another one, I mean, I've got enough extra screws wise and BNC connectors and battery holders. I bought 3 of those. I think it was a pack of 3 and a pack of 5 of BNCs, and of course the screws is 50 of each size. So the next one would be you know, a whole lot cheaper. If you did it by per item, I'd definitely have less than 30 bucks in this. So for a little bench frequency counter, that's pretty reasonable, and I think it looks cool. Anyway, have a great day. This is Electron Man. Please like and subscribe.